In this video, I'm going to do 3 energy and forces questions that are going to get more and more difficult through the video. Okay, so this question says, a train of mass 22 tons moves along a straight horizontal track. A constant resistive force of 5,000 newtons acts on the train. The power output of the engine of the train is 240 kilowatts. Find the acceleration of the train when the speed is 20 meters a second. Okay, so I'm going to draw a train out here so you can see what's happening. We've got a force of, let's just call it F for now, acting to the right, which is pulling the train forward, and a force of 5,000 newtons, which is acting to the left, which is trying to pull it backwards. We know that the resultant force is going to be equal to mass times acceleration. And we also know that force equals power over velocity. So we can say that F equals 240,000 because it's in kilowatts over 20, which is going to be 12,000 newtons. The resultant force is going to be that 12,000 take away the 5,000, which is acting backwards. And that's going to be equal to 22,000, which is 22 tons, times acceleration. This means that acceleration is equal to 7,000 over 22,000, which is 7 over 22 meters per second squared. Okay, so this next question says, a car accelerates from rest along a straight horizontal road. The car's engine produces a constant horizontal force of 4,000 newtons. At time t, the speed of the car is v meters per second, and a resistive force of magnitude 40 v newtons acts upon the car. The mass of the car is 1,600 kilograms. Show that dv over dt equals 100 take v over 40. Okay, so just like the last question, we can say that resultant force equals ma. And if we draw a little diagram out here, we can see that 4,000 newtons acts to the right and 40 v acts to the left. So we can say that 4,000 take 40 v equals 1,600 a. Now, the question is asking for dv over dt and not a. Well, dv over dt is the rate of change of velocity, which is just a. So we can say that 4,000 take 40v equals 1,600 dv over dt. If we rearrange this equation, we can get 4,000 take 40v over 1,600 equals dv over dt. If we divide this by 40, we can get 100 take v over 40 equals dv over dt, which is what the question wants. Part B says, find the velocity of the car at time t. Now, we already know that dv over dt equals 100 take v over 40. So if we just separate the variables, which you might have done in pure maths in year 1, we can see that the integral of 1 over 100 take v dv equals the integral of 1 over 40 dt. Okay, so if we integrate this, we get negative log 100 take v equals 1 over 40t plus c. Okay, so we already know that when t equals 0, v equals 0, because the first line says a car accelerates from rest. So if we substitute these values in, we get negative log 100 take 0 equals 1 over 40 times 0 plus c. This means that c equals negative log 100. Okay, we can now rewrite this equation and say negative log 100 take v equals 1 over 40t take log 100. If we rearrange this to get 1 over 40t, we can see that log 100 take log 100 take v equals 1 over 40t. Now, you should know from the laws of logs that that's just the same as log 100 over 100 take v. Now we can put e as the base for both sides, and the e and the log will cancel out. This gives us 100 over 100 take v equals e to the 1 over 40t. Now we just need to rearrange it to get v. So 100 equals 100e to the 1 over 40t take VE to the 1 over 40t. This means that VE to the 1 over 40t equals 100e to the 1 over 40t, take 100. If we divide both sides by e to the 1 over 40t, we can see that v is going to be equal to 100 take 100e to the negative 1 over 40t, which is the answer. This last question is a little bit more difficult than the other two, but I'm going to show you how to do it. Okay, so it says two particles, A and B, are connected by a light elastic string that passes through a hole at point O in a rough horizontal table. The edges of the hole are smooth. Particle A has a mass of 8 kilograms and particle B has a mass of 3 kilograms. The elastic string has natural length 3 meters and a modulus of elasticity of 60 newtons. Initially, particle A is held 3.5 meters from point O on the surface of the table, and particle B is held at point 2 meters vertically below O. The coefficient of friction between the table and the particle is 0.4. The two particles are released from rest. The first question says, show that initially particle A moves towards the hole in the table. Okay, so I've drawn a diagram here that's going to show what it looks like. So we've got the two particles A and B, which are going to be 3.5 meters and 2 meters away. We've got tension in the string, which is going to act towards the hole from both of them. And we've got a reaction force of 8 newtons on A and a friction of 0.4 times R, which is the reaction force, which is going to be going the opposite direction to T. And we've also got a weight of 3G acting on B. Okay, so first of all, we're going to find out what the tension is in the string. So we know the equation. It's going to be T equals lambda E over L. This is equals 60, which is the elasticity modulus, times by the extension, which is going to be 3.5, add 2, which is the total length now, take away 3, which is the natural length. That's going to be 2.5. So we're going to have 60 times 2.5 divided by 3, which is the natural length. This gives us 50 newtons. Okay, so the frictional force here is going to be equal to 8G times 0.4, as we can see on the diagram here. And that's going to be equal to 31.36 newtons. Now, because the tension is more than the friction, that's going to mean there's going to be a resultant force acting towards the centre of the hole, or just the hole, which means it moves towards the hole. The second part says, show that initially particle B also moves towards the hole in the table. Okay, so we know that the tension is 50 newtons and the weight on B is 3G. So that means that 50 take 3G is going to be the resultant force, and that's not going to be 0, so there's going to be a resultant force acting up. Or we can say that 50 is bigger than 29.4, which is just 3G. So that means B moves towards the hole. Part B says, calculate the initial elastic potential energy in the string. Okay, so we know that the extension is 2.5, the length is 3, and the modulus is 60. So we can say that 60 times 2.5 squared over 2 times 3 is going to be the elastic potential energy. That equation comes from lambda E squared over 2L, which is just the integration of the other equation we used in the last part. Now that calculation is going to give us 62.5 joules, which is the initial elastic potential energy in the string. Part C is the hardest part of the question. It's worth 7 marks. It says, particle A comes permanently to rest when it has moved 0.46 meters, at which time particle B is still moving upwards. Calculate the distance that particle B has moved when it is at rest for the first time. So we know that energy is going to be conserved here, so the energy initially equals energy finally. Okay, so from part B, we know that the initial elastic potential energy is 62.5. And we're also going to have some work done. So we're going to take away 31.36, which was the frictional force, times by the distance, which is 0.46. Okay, and the final energy here is going to be the gravitational potential energy, which is the mass, or the weight, which is 3g, times, we're going to call that distance h, which is how far it goes up. And then we're going to add on to that the elastic potential energy at the end. Okay, so the hardest part of this question is finding the right extension to use. So we can say that the extension is going to be 3.5 take away 0.46. That's what we know so far. And then we're going to add on 2 take away h, because that entire length below the table is 2 meters, and the height it moves up is going to be h. So the distance from O is going to be 2 take h. And then we're going to take away 3, because that's the natural length. This leaves us with 2.04 take h. If we substitute that into the equation, we get 2.04 take h squared times 60 over 2 times 3. Okay, so if we expand this out, we get 10h squared take 40.8h, add 3gh, add 41.616, add 14.4256, take 62.5. If we put this into the polynomial solver in your calculator, you're going to find that h equals 1.5552, or h equals negative 0.415. Now we're going to reject that answer of negative 0.415, because the height won't be negative here, because it moves towards O. We know that already. So that means the height equals 1.56 meters.